Good day everyone, I am Gian Duhina from ECA 112L, Section B15, together along with John Patrick T. Guzman and our core subject advisor, Miss Marian Sehera. This documentation will be separated into 4 agendas: theories and concepts, circuit and activity results, conclusion, and activity time-lapse. Phase shift keying or PSK is the digital modulation technique in which the phase of the carrier signal is changed by varying the sine and cosine inputs at a particular time. The PSK technique is widely used for wireless LANs, biometric, contactless operations, along with RFID and Bluetooth communications. The binary phase shift keying or BPSK is also called a two-phase PSK or phase reversal keying. In this technique, the sine wave carrier takes two phase reversals such as 0 degrees and 180 degrees. The BPSK is basically a double sideband suppressed carrier DSBSC modulation scheme for messaging being the digital information. The modulation of BPSK is done using a balance modulator which multiplies the two signals applied at the input. For a zero binary input, the phase will be 0 degrees, and for a high input, the phase reversal is of 180 degrees. By recovering the band limited message signal with the help of the mixer circuit and the band pass filter, the first stage of demodulation gets completed. The baseband signal, which is band limited, is obtained, and this signal is used to regenerate the binary message bit stream. In the next stage of the modulation, a bit clock rate is needed at the detector circuit to produce the original binary message signal. If the bit rate is a submultiple of the carrier frequency, then the bit clock regeneration is simplified. To make the circuit easily understandable, a decision-making circuit may also be inserted at the second stage of detection. The two op-amp models, ATA466-2, 5 voltage sources, 1 signal source, and 7 resistors are utilized in this BPSK modulator circuit. The first op-amp, ADA466-2, is connected to 2 voltage sources, each of which has a voltage source of 12 volts, while the second op-amp is the ADA466-2 is coupled to the same 2 voltage sources as the first op-amp. The remaining voltage sources, known as poles, are a signal source and a voltage source. The signal source provides a carrier signal with an amplitude of 1 volts and a frequency of 1 kilohertz, while the voltage source generates a square wave with an initial voltage of -1, turning on the amplitude, and this parameter has the time set of 1 picosecond delay and 1 picosecond rise, and 1 picoseconds fall, and the time on is 4 milliseconds, and the period is 8 milliseconds. Because the time on 4 milliseconds, the time off is also 4 milliseconds. The signal source is connected to a series of resistors with the same parameter of 5 kilohertz, 5 kilo ohms, and it connects to the op-amp and the NPN transistor to generate carrier signal. The square wave is generated by the NPN transistor which has a voltage source attached to a series resistor of 5 kilo ohms. To finalize the project documentation, here is the time lapse in where John Patrick and I created and simulated the given circuit for BPSK modulator and demodulator circuit.
Good morning, everyone. I will make a BPSK modulation and the modulation concept using AN LT Spice.